Here's an example where we're finding complex cube roots of 1 plus 2i and give our answers in that form separated by commas. There's an example answer. All right, so we are taking 1 plus 2i and, well, I should write out, we're supposed to find all complex, well, I don't need to rewrite those words. I don't know what I'm doing here today. 1 plus 2i, there it is. It says find all complex cube roots of that. So cube roots. So that, well, maybe I should write it out a little bit. Third roots of 1 plus 2i. That's what cube means, right? Cube means 3. Third roots. So find all the third roots. All third roots. All third roots. Complex third roots of 1 plus 2i. How do we do it? Well, I gave you a bunch of notes. And to help you with that, let me see. Let me actually go grab them for you. And here we go. The notes are right here. Here they are. So these are in the top of Module 5 for you. And roots of a complex number. Oh, actually, I've already got those for you. And let me put down this part as well. Okay, so, yeah, we got what we need here. Let me put this part in for us too. Okay, so if you come down here to this page, it says, how do you find the root of a complex number? If the question is in rectangular form, then change to polar form, see number 7 above. So the first thing we got to do is change to polar form. So let's go up here. Here's number 7. And this is changing rectangular form of complex number to polar form. What do you do? Plot the point to see which quadrant it is and calculate R. Okay, that's the first thing. So let's plot the point. So the point is, I'm going to go by bigger marks here. So, okay, so it says it's over 1 up to its right there. Remember, this is the real axis. The x-axis is the real, and the y is the imaginary. So this is the point right there, because it's over 1 up to I. So 1 plus 2i is right there. And they want us to calculate its r. R, which really is the length. It's how far out there to it. And you know how to find that. It's just a right triangle, isn't it? So r right here is just x squared. It's the square root of x squared plus y squared. That's why they say that formula. So that's going to be 1 squared plus 2 squared. Square root of 5. I'm just going to leave it square root of 5. I don't want a decimal right now. Do all that later. So r is the square root of 5. That's the length out to our complex number, 1 plus 2i. So now, that's the first step in changing forms. Plot the point, see which quadrant it is in, calculate r. Find the angle in degrees. Reference angle is tangent inverse of y over absolute value y over x. So we got to do that. So let's come on down here. So, oops, I'm supposed to erase. Reference angle is what it said. Tangent inverse, absolute value y over x. Tangent, so what's y? Remember this is x and this is y. So it's going to be 2 over 1. Tangent inverse of 2 over 1. Hit the button so you can make sure you're in degree mode. I'm getting, in fact, I'll just bring it down. Well, I'll put it right here. It's 63.4349. Better use a, in fact, I better use a ton of accuracy. Let me bring it down here. So the reference angle is 63.4349 1.4882 degrees. Okay, that's the reference angle. That may or may not be the actual angle. What does it say we do from there? Well, next it says, so that's the reference angle. And then part C. Currently, we only have the reference angle. Find the actual angle based on the quadrant. If you're in the first quadrant, no change. Second quadrant, the actual angle is 180 or pi minus the reference, and etc. for other quadrants. Based on the quadrant. What quadrant are we in? Oh, first, right? Right and up. First quadrant. They're both positive. First quadrant. What did it say for first quadrant? No change. So if we were second, third, or fourth, we would need to do something different to find the actual angle. So we don't need to make any change here. This is, we can just change this now to this is the actual angle. They're one and the same. Okay, so that's, so now we've got, well, the last step, complex number polar form is that R we found cosine theta plus I sine theta. So the polar, let's bring that down here. Again is R cos theta plus I sine theta. So that's going to be R. What's our R? Square root of 5. Square root of 5. And then we're going to go cosine of that angle. I'm just going to call it 63.4349 degrees. Maybe I can't fit in all the digits. Plus I sine of the same thing, 63.4349 degrees. Okay, so that's the polar form. We haven't done any rooting yet. That's the polar form of the number. That's all we've done is this. So we're down here on the root stuff. If the question's in rectangular form, change it to polar. That was all just step 1. Check. Step 2, question's now in polar form. Yep, it looks like that. Right. Now to find the nth root, find the nth root of the front number. Example, 5th root of this would be that to the 1/5. So find the nth root of the front number. Ooh, okay. So now we take the front number, square root of 5, and what root are we doing on this one? Third root. Third root. So we're going to take the third root of the square root of 5. Third root of that front number. Well, how do you do that? You take the square root of 5 to the 1 divided by 3. Did you see how it did that? On the that's what it said down here. Right? I gave an example. And I said, for example, if you had negative 243, you go negative 243 to the 1/5. That's the 5th root. It's 1 over 5. So the third root will be 1 over 3. The power of 1 over 3. Okay. So do that on your calculator. And your power button might be different on your calculator. You might have an X to the Y power button or an X to the blank, some calculators have. Or you might have that up arrow thing that my calculator has. So, okay, so start with the square root. Get that on your screen and then go to the 1/3 power. I'm getting, what am I getting? 1.307660486. There we go. Now that's the first part of our final answer. So find the nth root of R. Got it. Now find the starting angle, which is theta over n, and the difference angle, which is 360 over n. Starting angle and difference angle, both divided by n, theta and 360. Okay? So let's take theta, and let's take 360. So starting angle, theta divided by n, and then over here we'll have the difference angle. Which is 360 degrees divided by n. What's n? N is our root amount. N is third root. So this is going to be theta. So what's our theta? You got to grab our theta right here. That's probably enough accuracy. We'll just grab it right there. There's our theta. So I'm going to calculate that as 63.4349. Well, just to be safe, I'm going to put the rest of the digits, degrees, divided by n, which is 3. So 63.43494882 divided by 3. So I'm getting a starting angle of 21.14498 degrees. And then the difference angle is 360 divided by n. So that's 360 divided by 3. Because again, n is 3. We're doing a third root. So that's 120 degrees. Okay. So what do we do now? Now if you come on down, we got our starting angle and our difference angle. We're almost there. The first angle is your starting angle. The second is you add the difference. You just keep adding the difference. So you have your starting and then just keep adding the difference. Okay. So first angle is the starting angle, 21.14498 degrees. And then the second angle is going to be the starting plus the difference, 120. So plus 120, well that's 141.14498. So there's our first angle, there's our second angle, and then our third angle. What's that going to be? It's going to be the last answer, the 141.14498 degrees, plus 120. Right? The note said you just keep adding the difference, whatever that is. So that's going to be 261.14498 degrees. So there's the third angle. Okay, so we got our 3 angles now. We're almost there. And then that leads us to our 3 answers. The first root is that root we found in the front, cosine first angle, sine first angle. The second is that root, cosine second, sine second, etc. All right, so this is not an easy process. First root is going to be, okay, that number in the front, where was that? Here. 1.307 blah, blah, blah. 1.307660486. Probably more digits than I need. Times cosine of the first angle. What's our first angle? 21.14498 degrees. Plus sine of that very same angle. I, forget the I sine of that very same angle, 21.14498 degrees. Yeah, so don't forget that I. It's important. That's your first root answer. Let's do our second root. Second root is the same number in the front, 1.307660486. Bracket, it's a little bit too big of a bracket there. Bracket, cosine, and this time the second angle. So that's 141.14498 degrees plus I sine of that same second angle, 141.14498 degrees. And then the third root, 1.307660486, bracket, cosine of that third angle, 261.14498 degrees, plus I sine of that same third angle, 261.14498 degrees. There's our three roots. Third root, yeah, three roots. Now, last step, if you go back, think if that's not enough, feel like enough? So we got our roots. If the answers are required in rectangular form, then change each polar answer to rectangular form, distribute the number in front each time. Just distribute the number in front. Yeah, so if they want you to stop here, great, you're done. If they want you to go on, like on this one, they want me to go all the way on, where are we at? Oh, here it is. Here's the question. I lost the question. They want, see what they want in the end here? They want the answer in rectangular form with numbers and eyes. So we got to keep going. One more thing. We just take this number in the front and go boom and boom and multiply in your calculator. Times the cosine of that, times the sine of that. Write down what you get. I'm going to do it right now. 1.307. How far do they want it rounded? They did not say, but it looks like all their answers are rounded two places. Two places, two places. Okay, so I'm going to do that, round to two places. So 1.307660486 times cosine 21.14498. I'm getting 1.22 plus I, and then take that number right here times the sine of that. So 1.307660486 times the sine of 21.14498, and I'm getting 0.47. Oh, that's as far as we need to go, huh? And usually we put the I in the back. You don't have to. 0.47I. So there's my first actual answer. Next one, same thing. Take this, distribute, distribute. So 1.307660486 times the cosine of 141.14498. I'm getting negative 1.02. And then the last spot, 1.307660486 times the sine of 141.14498. I'm getting plus 0.82I. There's my second complete root answer. And for the third, same thing, distribute, distribute, just distribute that number in the front. 0.307660486 times cosine 261.14498, and I'm getting negative 0.20, and then last multiplication 0.307660486 times the sine of 261.14498. I'm getting minus 1.29I. So there are my three final roots. So they want you to put all three of those separated by commas. So there's the three roots, each rounded to two places. That was a lot of work, wasn't it? So what do we do? Recapping. We started with these this complex number in rectangular form. We graphed it, found its r, square root of 5, right, by the Pythagorean, and then found its angle. Reference angle is tangent inverse, y over x. Got the reference angle, then we converted it to actual, but realized it's in the first quadrant, so that is the actual. Then we went to polar form, which is r cos theta, I sine theta. The r is root 5. Cosine theta plus I sine theta for that angle we got. And then we had to third root that. Which meant what? The third root said, third root the number in the front, the root 5, so I took the root 5 to the 1/3 power, got that number. And then I took the angle and divided by 3. and took 360 and divided by 3. Got what's called the starting angle and the difference angle. And then that starting angle, we just add the difference angle every time, get these 3 answers, and then we write those as our 3 roots, and then distribute, distribute, distribute to finally get rectangular form of our roots.